Hello, seniors A through E. I will now be solving problem from your worksheet 2.3, problem number 10, also known as the bunny problem. Okay, see, I put little bunny ears on. Oh, that's cute. Okay, all right, so here we go. So it says the velocity of a bunny is given as a function of time by the following. Velocity at time t is, in fact, 4t minus 3t squared, where v is in meters per second and t is in seconds. A, find the average velocity over the interval from 0 to 2 seconds. All right, so if you got this one wrong, my guess is the reason that you got it wrong is because you said, oh, I'm looking for average velocity. And we learned last year that you can calculate average velocity by doing VF plus VI over 2. So all I need to do is, my time is going from 0 to 2, so I can find the velocity after 0 seconds, find the velocity after 2 seconds, and then average them. Yes? No. You can't do that. Does anybody remember why? What do you got?
It has to be constant acceleration.
Good. Very, very good. This equation, you guys, I cannot stress this enough. This, hands down, was the most common mistake on this test last year. You can only use this equation here that I just circled in red if the acceleration is constant. So, how do I know the acceleration is not constant? Sorry, what did you say? Right, if there was a variable in it. But so how would I use this to find out information about the acceleration? If you know the velocity, you guys, how do you find the acceleration? Take the derivative, right? So if I take the derivative of this, I'm going to get 4 minus what? 6t. So the fact that it depends on t is telling me that the acceleration is not, in fact, constant. So let me pause there for a minute. Does that all make sense? Acceleration is not constant, so I can't use this. Yeah, we got that.
Can you, so it's that you can never use the VF plus VI if it's not constant?
Correct.
The other way to do it is like the delta t divided by delta, or
Delta
x divided by delta t. Can you use that for either?
Yep. That one, that is the definition of average velocity, so that always works. Okay. Good?
Yeah, yeah.
All right, so we're all good with why this doesn't work, yes?
Yeah.
All right, so what does work is exactly what Kat just said. So the only way, if your acceleration is not constant, the only way you can calculate average velocity is by finding your change in position and dividing it by the time that change takes. So you're finding, on average, how far you travel per unit time. Good? So that brings up the question then, how do we find the displacement? Right, so remember, we're looking for not position, but change in position, right? Between point A and point B, between 0 and 2 seconds. So we're going to take an integral, but more specifically, it's a, what kind? Definite integral, right? Because we've got these two fixed endpoints, right? Follow? So here we go. So our displacement then is the integral from time 0 to time 2 of my velocity as time changes. Okay, remember the fact that this is with respect to time tells us that my endpoints have to be times. Clear? All right, so now I can plug in my numbers. So the integral from 0 to 2, let's see, v of t, that's this mess, 4t, oops, minus 3t squared dt. Cool? All right, so remember, anytime you're taking an integral, the question should be, what do I have to take the derivative of to get this? Right? So what would I have to take the derivative of to get 4t? The derivative of what is 4t? It's 2t squared, right? Everybody good with that? Because then you bring down the 2, 2 times 2 is 4, reduce your exponent, leaves you with t, right? Minus what I have to take the derivative of to get 3t squared. This t cubed. All right, now I've already taken my integral, so I can get rid of the squiggly s, but I replace it with the big line that says evaluate it at 0, evaluate it at 2, and then find the difference, right? So let's see, if you plug 2 in, let's see. Oh no. So if you plug 2 in, you get 2 times 2 squared minus 2 cubed. Minus, if you plug 0 in, you're just going to get 0. So this is 8 minus 8. Oh, you just get 0, don't you? All right, and that 0 is our displacement. So our average velocity then is displacement over time. 0 divided by anything is 0. Follow? Yes?
Are you allowed to just plug the integral into your calculator instead of doing the math?
Yep, so here's the deal. You are allowed to use a calculator on the AP test. You are allowed to use it to do the calculus if you want. Just write a note so that the grader knows how you got your answer. Okay? I used my calculator to take an integral. Or I used my calculator to find the maximum of this curve. Or whatever. Cool? Good? Cool. Don't write out what you used the calculator to do. Don't just write, I used my calculator. Good? All right. Questions? All right. All right. Part B. What is the maximum velocity the bunny reaches? So here, there's a couple options again. So here's my velocity equation. So option 1 is if you know how to do this on your calculator, you can graph this and find the maximum, right? And I believe there's value in knowing how to do it by using calculus. So in general, if you've got a function, how do you find the maximum? Okay, so in this case, acceleration. Why is acceleration important here? Somebody said that. There you go. There you go. So in general, to find the maximum or minimum of a function, you take the derivative and set it equal to 0. Right? And you're right. In this case, the derivative is acceleration. Follow? Any problems up to there, you guys? Okay, so for part B, find max velocity. So you're going to set the derivative of velocity equal to 0, right? Okay, so let's see. So acceleration happens to be the derivative of velocity with respect to time. So I'm going to take the derivative with respect to time of velocity, which is this mess. 4t minus 3t squared. I'm being really detailed with my notation here. You don't need to be that detailed, but I just want to make sure you guys get used to seeing all these d's, because I know they can be intimidating. So I think the more you see them, the more they'll start to make sense. So everybody good with how this and this are the same thing? Kat, you doing okay over there?
Yes.
Yeah? Okay. Wasn't that you that was asking about this? Maybe that wasn't you.
What? Oh, no, that was...
It wasn't you. All right, everybody good? All right, so what's the derivative of 4t, you guys? 4. What's the derivative of 3t squared? 6t. All right, so there's my acceleration. I'm going to now set it equal to 0. Oh, that means 4 equals 6t. Oh, that means t is 4/6, which is 2/3, which is 0.6 repeating seconds. So now how do I find my maximum velocity? Plug it back into the velocity equation, right? And it gives you 1.3 meters a second. Again, remember the answer key was wrong. Got this correction over here. And so the velocity at 0.6 seconds is 1.3 meters a second. So there's your answer for part B. Everybody good? Anybody ungood? Nicole, you okay? You already set? Thomas, you okay over there?
Yeah, I'm good. Sorry.
No, you're okay. It was a genuine, I was making sure you're okay. All right. So we're good?
Yes.
All right. Question C says the bunny turns around 2 times. How far does he travel between those 2 times? So, a couple steps to this one. So what's the first thing I need to do? He turns around 2 times. How far does he travel between those 2 times? So yeah, what do you got, Kat?
Do you need to find an equation for x?
Say it again. Find an equation for.
X.
Eventually, we will need to do that. Yes. So once we have that, what would we do? I think there's one other piece of information we need before that will help us. You got an idea on it?
Where the velocity is zero, it stops around.
Okay, good. Yeah, we need to know the 2 times at which it turns around. So we can then figure out how far it traveled between those 2 times, right? So let me pause there for a minute. Does that make sense why we need to know that? Okay, yeah, we got to figure out the 2 times at which it turns around. And so then Emma even took us a step further and said, well, wait a minute. The times at which it turns around are the times at which the velocity is 0, right? Because look, when does the bee turn around? Oops, if you hadn't hit the ceiling. When does the bee turn around? When the velocity is 0, right? He has to slow down, stop moving one way, and then begin going the other way. Good? So, this board is getting super cluttered. So, let's do this. So here's what we know. We know our velocity at time t was 4t minus 3t squared. And so we just decided that the bunny is going to turn around when the velocity is 0. So I'm going to use this equation and find out when the velocity is 0. So you can either try to use the quadratic formula, or this actually factors fairly easily, and you get t times 4 minus 3t. So that means either t is 0 or 4 minus 3t is 0. This bottom equation tells us that t is 1.3 seconds. Is everybody good up to there? All right, so now that I know the 2 times at which it turns around, what Kat said before was warm. You said find the position as a function time. We can't exactly do that because there's no way we'd be able to find that c value.
It's the difference between the 1.3 and 0.
Exactly, and so we're doing a definite integral to get a change instead of an indefinite. Cool? So yeah, so she's exactly right. So now we can go, oh, well, displacement is the integral from 0 to 1.3 seconds of v of t with respect to time. So now it's just an integral, just like we did in part A. So it's literally the same integral, right? So you get 2t squared minus t cubed, evaluated at 0 and at 1.3. Plug in your numbers, and you end up getting a displacement of 1.18 meters. And again, remember, you plug in the top number, and then minus what you get when you plug in the bottom number. Yeah. Trista.
It says it turns around twice, like 2 times.
Mhm.
So
Once at 0
oh,
and once at 1.3
okay.
seconds. Does that make sense? Because there are 2 times at which the velocity is 0, and therefore 2 times at which it turns around. Now, I guess to be clear, that maybe that's a little bit sloppy, because if time starts at 0, I guess it wasn't moving before that. Do you know what I mean? But sometimes in these problems, they do allow the time to go negative, which is weird. But is that good? Did I answer your question?
Yeah.
Okay. Other questions, you guys? All right, so that was number 10, the bunny problem. Where's my recorder? Does anybody play the recorder? All